Welcome to a lesson with Dr. Powell. Let's take a look at how we might begin factoring something that looks like this using synthetic division. First, we use the idea that we talked about in the last video, which is sometimes called the rational roots theorem. Roots mean like solution when you set it equal to 0 or zeros or whatever. Rational just refers to a nice fraction. That's just another fancy word for that. And then they call it the rational roots theorem, but really it's just what we were talking about, where the things we want to try are going to be factors of the constant divided by factors of the leading. So in some sense, we could kind of list out all the possibilities. Factors of 6 are 1, 2, 3, and 6, but plus or minus, all of them. Lots of things to try because we have to try all those things all over factors of the leading. Plus or minus 1, plus or minus 2. In these videos, we'll actually demonstrate how we can take this list and narrow it down quickly to get what we want. But for now, I won't teach you how to narrow that down. We're just kind of get a feeling for what we're about to do. What we do is we try to just plug in all the options of taking fractions of numbers up here over numbers down here, all the different possible options of doing that. And you plug them, and what you do then you plug them into the function using synthetic division. Let's see kind of how this list would look a little bit, and then I'll actually give you one that works, and we'll see what we want to find. So this list really, well, let's see, we have 1. So if we divide by plus or minus 1, we're basically going to get that list again, plus minus 1, plus minus 2, plus minus 3, plus minus 6. If we divide by plus minus 2, we're actually going to get, well, if we divide that by 2, it's just going to get 1, that's 3 halves, and 3. Really, the only thing that we're going to be adding to this top list when we divide by 2 is plus minus a half, plus minus 3 halves, and then we're left with everything else. Plus minus 1, plus minus 2, plus minus 3, and plus minus, let's see, 6. So these are all the options that we have of potential nice roots. And based upon those roots, we can actually figure out what the factor would be. Okay, well, let's just get started and see what we can do. First of all, I'm going to give you one that actually works. It's plus 2. Let's see that in action. So 2, and then let's look at this. This is 2, 1, -7, and 6. All right. And let's see, we drop the 2, we get 4, we add, we get 5, we get 10, we add, we get 3. Oh, that's a -6. Yeah, that's a -6. That's important. 6, and then we get 0. Okay, good. We got a root out. Not only did we get a root, but we actually got a factorization. This guy right here is actually equal to, because it divides evenly, the quotient times the divisor. What was the divisor? Well, you plug this in to make the divisor 0, so the divisor better be x minus 2. Then you multiply by the quotient, which is 2x squared plus 5x plus 3. We've actually factored it. Look at that. We've taken this. By finding one root, we actually find a whole factorization. Beautiful. That's what synthetic division does for us. If you know one, you know how the rest looks as a factor. Now, at this point, since you got down to a quadratic, you could just factor this normally as you would a quadratic, which is just a backwards FOIL process. You know that these two guys need to multiply together to get you 2x squared. So I'm going to put a 2x and an x. You know that these two guys need to multiply together to give you a 3. But then strategically, we need to place things so that the middle and the outside right here add together to give you the middle. And this works right here. This is the nice factorization. So we have just factored it, and we can see all the roots actually. So from iced off of 1, we got the rest. So we have x is equal to, set this equal to 0 and solve. You get -3 divided by 2. You can check it. Even if you plug it in, you'll see that it works. Then over here, you'd get x is equal to -1. So we're able to find all 3 roots or zeros of this polynomial by knowing one of them, and a synthetic division, because the synthetic division gives a factorization, and we could further factor this as a quadratic. Thanks for watching.